Hello, welcome to another section of Math. Let's look at this question. Solve integral 1 over square root of 4 minus 9x squared dx. Solve integral 1 over square root of 4 minus 9x squared dx. This problem here, we are going to solve it using trig substitution. So in this video, we are going to learn how to use trig substitution to solve integral problem. I don't know, maybe you can use substitution approach to solve it, or maybe integration apart, or maybe other approaches. But well, you can try other approaches if you can use any of them to solve this problem here. But in this video, I'm going to use the trig substitution approach to solve this problem. Okay, so let's get started without wasting much time. As usual, we will write our solution first. Okay, this is the integral question that we are going to solve. So let's bring it down here. Okay, 1 over square root of 4 minus 9x squared. Here, we are going to apply the trig substitution directly from here. Okay, so trig substitution. Now, to use the trig substitution, with trigonometry, we are talking about what? Ratios of what? Trig ratios like sine, cosine, tangent, secant theta, cosecant, cot. That's what I'm talking about when I say trig ratios. Okay, so how are these ratios used in solving problem of this nature? Well, to do that, we need a right angle triangle. Okay, so let's draw a right angle triangle. But before we draw a right angle triangle, 4 minus 9x squared is what we are going to use in drawing our right angle triangle. The figure that is going to be written on the sides of the triangle are what? This and then that. But you will not write the whole of this 9x squared there, or maybe the whole of this 4 there. The triangle, we write these numbers on the sides of the triangle by applying what? Pythagoras theorem. So since we are going to use Pythagoras theorem in writing these numbers on the sides of the triangle, this 9 here can be written as this 9 x squared here can be written as what? 3x all squared. And then this one is what? This one is 4 and can be written as well 2 raised to the power what? 2. So on the triangle, we will not be seeing this and this, but rather we're going to see 2, 3x, and then we apply the Pythagoras theorem, which will give us what? What is here? Okay, so you let's draw the triangle and see what will happen. Okay, there is a right angle triangle, though the symbol for the right angle triangle is not what there. Now, mind you, with trigonometry ratios, it normally goes with what? Angles. So let's locate our angle. But please, when you are locating your angle, you just have to be careful. Where you locate you position your angle symbol depend the kind of ratios you are going to use. Okay, So don't just position it what anywhere. Now here I'm going to place my angle theta here. Once I place my angle theta here, now this side of the triangle become my opposite, and then this horizontal here line here become my what adjacent, and the line which is facing the 90 degrees symbol, which is what something like this one, something which is drawn like this. This line which is facing this angle is what 90 degree. This line we call it what the hypotenuse. But if you were to be under trigonometry as a topic on its own, we could have called it what line of sight when you are dealing with angle of the elevation or what depression. After that, we call this line of sight. It's the same right angle, but we call it line of what sight. But here you're going to call it what hypotenuse because of the application of what Pythagoras theorem. So let me draw my angle. Okay, the angle here is what theta. The angle here is what theta. Okay, so now that theta is here, what is going to be here and then here? But mind you, whatever that you put here, this side is the opposite, and then this side is for the adjacent, and then this side which is facing this angle is what the hypotenuse. So if you pick something from here, that is opposite. Okay, so it is 4 minus 9x squared. 4 minus what? 9x squared. Because it's 4 minus 9x squared. So, A here, B here. To get this side is A squared plus B squared. It will give you what? Maybe C squared. And when you want to find C, then we take square root of both sides, and C will be equal to square root of A squared plus B squared. Okay, what of if it is, let's say, C is here and then B is here, and then we want to find the side like A? That is going to be C squared minus what? B squared is equal to what? A squared. And then when we take square root of both, we're gonna get A squared is equal to C squared, square root of C squared minus what? B squared. Okay, so since it is 4 minus 9, we are going to position the 2 here. I'm going to position the 2 what? Here. And then the 3x, we are going to position it what? On this side. It's going to position it on dot on this side. Okay, so this is our 3x, and then this is our 2. Now to get this adjacent side, or opposite adjacent, to get this adjacent side, we are going to subtract this one from this. That is going to be square of this one minus square of the whole of this is equal to what? The square of this. And then we take square root of that, and that will give us what? This side will be equal to square root of 4 minus 9x squared. 4 minus 9x squared. So you see how we write the numbers or the variables on the triangle. You do that according to what Pythagoras theorem was law. If it is 9, don't just write a 9 here, because when you do and you square it, you are not going to get 9, but rather you're going to get 81. So if it is 9, you just take square root of 9, that is for 3, and then you write that 3 on the triangle, because at the end of the day, when you square this, you get your 9 back. Okay, now that our triangle is drawn, let's consider how we can use our hot ratios. How are we going to choose our ratios? Well, always when you are doing trig substitution, in integrals, make sure you always go for the easier ones, those that does not require much work in terms of differentiating. Okay, so when we pick sine, that is sine theta. sine theta. Remember the sign is what? So that is opposite over the what? Hypotenuse. Opposite over the what? Hypotenuse. Or let's say ka, that is cosine is equal to adjacent over the hypotenuse, or twa, that is tangent is equal to opposite over the what? The adjacent. Okay, now when we pick ka, it's going to be this one over this. Differentiating will require much work. When you pick twa, it's going to be this over this, also require much work. But when you pick sine, it's going to be maybe this over what? This. Okay, and that one is quite easy to differentiate as compared to ka and then twa. So our sine theta, remember you always pick the ratios together with what? The angle. That means if you want to find this angle here, using sine theta, is going to be sine theta is equal to the fraction formed by the opposite and then the hypotenuse. If this were to be a fraction without any variable, then you take sine inverse of this one and it will give you the angle here. But that is, we are not looking for any angle. We just want to, get something like this and then put it into our integrals and then we solve our problem. Okay, so sine theta is equal to 3x over 2. 3x over 2. Now mind you, at the end of the day, we will have to find what is going to replace the x, and also you have to know what is going to replace what? X. But here we are having sine theta is equal to 3x over 2. So what are we going to do? Let's make x the subject. So you're going to multiply both sides by 2 over 3. 2 over 3. And when you do that, x will be equal to 2 over 3 sine theta. So x 2 over 3 sine theta is equal to x, or x is equal to 2 over 3 sine what? Theta. Now we can differentiate. This is going to replace x. This one is going to replace what? X. But what is going to replace what? Dx in the theta world. Well, to find out, what do? We differentiate. Okay, so let's differentiate this one. Now, when you are to differentiate something like this, just forget about the constant. Differentiate this one, the ratio here. Now, the derivative of sine theta is what? Cos theta. Then you multiply it by this one. We know the derivative of what? X, which is what? Dx. So this one is going to give us 2 over 3 cos theta d theta is equal to what? Dx. So when you go to the integral in the theta world, as we are entering, we're going to replace this one with what? This, and then x with what? 2 over 3 sine theta. Okay, so let's replace them. Good. Now after replacing them, this is how it's going to look like. Yeah, a little bit confusing, but you don't worry, at the end of the day you will be able to figure it out. Here it was 9x squared. Please mind you, though you can find another ratio that can replace the square root of 4 minus what? 9x squared, but from the right angle that we drew, there is no ratio that can replace it directly. When we pick cos, okay, when we pick cos, from that triangle, when you pick cos, you are going to get square root of 4 minus 9x squared divided by what? 2. That is what you are going to get, by that one will not replace unless maybe you write another equation that will isolate what? This one, for you to know what is this one will be equal to. Okay, so if you don't get something to replace the whole of square root of 4 minus 9x squared, don't just worry, because in the square root where we are having 4 minus 9x squared, we know what is going to replace what? X. And eventually when we replace x there, as we are computing it or as we are working it, that is going to what bring the ratio that which could have what replace that what there at the end of the day. So don't just worry. You just follow what you are doing. At the end of the day, you get it. Very simple. It's not that difficult. Okay, so here the original question was 1 over this, but when we come here, we know what is replacing x in the theta was, that is this one, but it was squared, so that's why it is squared here. And we know that this one is replacing what ds, so that is why this one is what here. Okay, now when you open the bracket, we're gonna get 4 over 9 sine theta, 4 over 9 sine theta squared. 4 over 9 sine theta squared. But mind you, this one is constant. It can come out of the integration, or it can be written at the back here, and then we focus on what is on the inside. You know, with constant, we always bring it out of the integration. I will always bring at the back of the integration symbol. Okay, so when you bring it out, this is what we are going to get. So as I said, 1 times this one will give us what? Cos theta, and then 4 minus, when you come here, 4 minus 9 into bracket. Now when you square this, you're gonna get 4 over 9 sine theta, 4 over 9 sine theta, 4 over 9 sine theta, 4 over 9 sine theta squared. Sorry. Okay, so here when you open the bracket, this 9 and this 9 will cancel out, and to be left with what? 4 sine theta squared, 4 sine theta squared. And with 4 sine theta squared, we can factor out what? The 4. We can factor out what? The 4. Okay, now after cancelling 9 and 9 out, that is what you have gotten. That is 4 minus 4 sine theta squared. And as I was saying, from the subtraction law or multiplication law of said, square root of a can be written as square root of a times square root of b can be written as square root of what? ab. And also square root of a times b can be written as what? Square root of a times what? B. So here we can factor out the 4. And when you factor out the 4, remember all of them is under what? The square root. Applying that multiplication law here, the moment you factor out the 4 become also what? Square root will also what? Remain on the 4. So when you factor out the 4, you are going to get square root of 4 times square root of 1 minus sine theta squared. When you factor out this 4 here, when you bring this 4, factor out means to bring it out outside. Okay, so now this one here is the same as what? This. When we expand this one, you're gonna get what? This by applying the multiplication law of what? Said. And also applying that multiplication law of cell to this one. That is what we have gotten at the end of the day. Now, what is the square root of 4? Now, the square root of 4 is what? 2. But remember, it is it's a denominator here. So when you bring that 2 outside, it's going to be what? 1 out of 2. Not just 2, but 1 out of what? 2. So when you bring it outside, you're going to multiply this one. So you're going to get 2 over 3 multiplied by 1 over 2. And then when it comes to inside of the integral, here 1 minus sine theta squared. From trig identities, cos squared plus sine squared is equal to what? 1. So when you make your cos the subject, you're gonna get 1 minus what? Sine squared. So this one is equal to what? Cos theta squared. Cos theta squared. Okay, good. As I was saying, square root of 4 will give us what? 2 here. And then this one will give us what? Cos theta here. Now, as I said earlier on that, this 2 here is in denominator's position. So when you want to bring it out, it will be what? Fraction. The numerator or the coefficient of this one is what? 1. So that 1 over this one will give us what? That will give us what? Half. So here we are going to bring that half outside here, and that is going to be 2 over 3 multiplied by 1 over 2. And then when you these two will cancel out with this square root sign, and to be left with what? Cos theta. Okay. Okay, good. Now cos theta, or let's start from here first. Now 2 over 3 times 1 over 2 give us what? This and this will cancel out to be left with 1 over 3. And cos theta divided by cos theta will give us what? 1. You're gonna have 1 over 3 integral 1 d theta. 1 d theta. Don't bother bringing the 1 outside, because at the end of the day, no matter what you do to it, there will still be another what? 1 there. Now the integral of this in the theta world will give us what? That's going to give us what? Theta. So you're gonna get 1 over 3 theta. 1 over 3 theta. So that is the answer at the end of the day. But we are in the theta world. We have to go back to where we came from. That is what the x world. But in the x world, even where we were making the substitution, we didn't see anything that was equated to what? Theta. But rather we saw that sine theta was equal to something. So if you want to find theta, it's a matter of making theta from that particular, making theta the subject from that particular equation. That is, sine theta is equal to, let's say, 1, and then we make theta the subject from that equation by taking sine inverse of what? Both sides. Okay, so but we know that sine theta is equal to 3x over 2. 3x over 2. So here, as I said, from this equation, you're going to make theta the subject. Okay, so to get theta, you're going to take sine inverse of both sides. Sine inverse of both sides. So when we take sine inverse of this one, it will give us what? Theta. And when we take sine inverse of this one, it will give us what? 3 sine inverse of 3x over 2. 3x over 2. So theta is equal to 3x over 2. 3x over 2. But yeah, what is the answer that we had? The answer is 1 over 3 theta. And now we do that theta is equal to sine inverse of 3x over 2. So when you replace, you're going to get 1 over 3 sine inverse of 3 over 2. 3 over 2. So that is the answer to the integral question in the x world. In the x world. So let's conclude. Therefore, this integral here is equal to 1 over 3 sine inverse of 3x over 2 plus c. 3x over 2 plus c. I hope you like this video, and I hope you didn't get confused or what, get lost, and I hope you were able to get some understanding from the approach that we use. Yeah, I hope so. I hope so. I hope so. I hope so. So guys, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.